Welcome to our video on time series forecasting. In this video, we will explore what time series forecasting is, why it's important, and how it can be applied across various fields. So, what exactly is a time series? A time series is a sequence of data points, typically measured at successive points in time, often at uniform intervals. Think of it as a way to analyze data points that are spread out over time, a powerful tool in data science. Understanding time series is crucial because it helps predict future values based on historical data. Forecasting, on the other hand, uses this data to predict future trends and patterns. This is invaluable in sectors like finance and weather forecasting. Throughout this video, we will delve into different forecasting methods, look at common challenges, and explore real-world applications. By the end, you'll have a solid grasp of what time series forecasting entails and how to use it effectively in various domains. Let's get started and dive deep into the world of time series forecasting. In this segment, we'll navigate through the foundational elements of time series data. It's not just a collection of values over time, but a rich tapestry woven with trends, seasonality, and noise. Understanding these components is essential for any aspiring data scientist or analyst. Trends indicate long-term movements, showing overall increases or decreases. Seasonality represents periodic fluctuations at regular intervals, such as weekly or monthly patterns. Noise is the random variation that can obscure underlying patterns. By breaking down these components, we can better interpret and forecast future values. This sets the stage for more advanced forecasting techniques we'll explore in later segments. Identifying these elements in your data leads to more accurate and reliable forecasts. Stay tuned. This knowledge is the cornerstone for tackling the intricacies of time series forecasting. As we delve into the world of time series forecasting, it's essential to recognize common challenges. Principal among them are data quality issues. Poor quality data can skew forecasts, making accurate predictions nearly impossible. Then, there's the problem of handling missing data. Gaps in your dataset can disrupt continuity and accuracy. Equally daunting is dealing with outliers, unexpected data points that don't fit the pattern. They can distort results and lead to misleading forecasts. Understanding these challenges is the first step in overcoming them. We'll introduce specific strategies to address each, ensuring your forecasts are as reliable as possible. Next, let's explore the various forecasting methods you can use. Now that we've covered the common challenges of time series forecasting, let's explore the various forecasting methods available. Today, we will cover an overview of these methods and underscore the importance of choosing the right one. Firstly, we have the moving average method. It smooths out short-term fluctuations to highlight longer-term trends. Next, there's exponential smoothing, which assigns exponentially decreasing weights to past observations. For more complex patterns, we use the ARIMA model, a powerful tool combining autoregression, differencing, and moving averages to deliver robust forecasts. Each method has its strengths and weaknesses, making the selection process crucial. The right choice hinges on understanding your data and specific forecasting needs. Accurate predictions come from an informed choice of method, preventing costly errors and enhancing decision-making processes. As we move forward, you'll learn how to apply these methods step by step. In this segment, we delve into the moving average method, one of the simplest yet effective forecasting techniques in time series analysis. The concept of moving average smooths out short-term fluctuations and brings longer-term trends into focus. By averaging a set number of past observations, we can create a line that highlights the underlying pattern, making it easier to predict future values. Implementing a moving average is straightforward. Select a specific period, such as 5 or 10 data points, then calculate the average of those points. As you move forward in the data series, continue recalculating this average by dropping the oldest point and adding the newest one. This method filters out the noise, giving you a clearer picture of the overall trend. The true strength of the moving average lies in its versatility. Whether you're analyzing stock prices, weather patterns, or sales data, this method can help you make sense of your time series data with minimal complexity. Stay tuned, as next we'll explore the exponential smoothing technique, taking our forecasting skills one step further. Welcome to this detailed look at exponential smoothing, a pivotal technique in time series forecasting. Exponential smoothing assigns exponentially decreasing weights to past observations, ensuring recent data has a greater impact on the forecast, crucial for capturing trends accurately. To apply exponential smoothing, select a smoothing factor often denoted as alpha. Alpha ranges between 0 and 1 and determines the weight of the most recent observation. A higher alpha means more weight on recent data, while a lower alpha spreads the influence over a longer period. The formula for exponential smoothing is simple yet powerful. The new forecast is the sum of the previous forecast multiplied by 1 minus alpha and the actual observed value multiplied by alpha. This recursive application enables the model to adapt continuously as new data becomes available. By using exponential smoothing, you can reduce noise and make your time series data more predictable. It's an excellent method for short-term forecasting, especially when dealing with data that has irregular patterns. Next, you'll see how exponential smoothing compares with other methods like the URIMA model, providing a robust toolkit for your forecasting needs. Welcome to the segment on the URIMA model, one of the most powerful tools in time series forecasting. URIMA stands for Autoregressive Integrated Moving Average. This method combines three key aspects: autoregression, differencing, and moving averages. First, autoregression uses past values to predict future values. By creating relationships between past and future data points, autoregression can capture trends in your time series. Second, differencing helps make the time series stationary, crucial for accurate forecasting, as it ensures that the statistical properties of the series are constant over time. Third, moving averages smooth out short-term fluctuations and highlight longer-term trends. By averaging the data over a specified period, moving averages help reduce noise from random variations. To apply the ARMA model, start by identifying the order of autoregression P, the degree of differencing D, and the order of the moving average Q. These parameters are crucial for tailoring the ARMA model to your specific dataset. Once these parameters are set, you can fit the ARMA model to your data and generate forecasts. Next, you'll see how to evaluate the accuracy of these forecasts and improve your predictions using various metrics. Evaluating the accuracy of your forecasts is a key step in the time series forecasting process. Without proper evaluation, you might not know how reliable your predictions are. Several metrics can help assess forecast accuracy. The mean absolute error, MAE, measures the average absolute errors between the predicted and actual values. The mean squared error, MSE, squares the errors before averaging, giving more weight to larger errors. Finally, the root mean squared error, RMSE, takes the square root of the MSE, providing a measure more interpretable in the context of the data's scale. Understanding these metrics and their implications can greatly enhance the reliability of your forecasts. Evaluations are not just numbers, they inform you about the performance and potential areas for improvement in your modeling approach. Stay tuned, as the next segment will delve into real-world examples where these evaluation metrics truly shine. Time series forecasting isn't just a theoretical concept, it's widely applied in our daily lives. Let's delve into some real-world applications to understand its significance better. In the business world, time series forecasting plays a crucial role in predicting sales, managing inventory, and making informed strategic decisions. Companies leverage these forecasts to remain competitive and respond proactively to market changes. In the finance sector, particularly in stock market analysis, time series forecasting is indispensable. Analysts use it to predict stock prices, identify market trends, and manage risks. Accurate predictions can lead to better investment decisions, offering a significant edge in a volatile market. Another critical application is in weather prediction. Meteorologists use time series forecasting to predict weather patterns, which is vital for agriculture, disaster management, and daily life. Accurate weather forecasts can save lives and help in planning better for future climatic conditions. Each of these examples underscores the versatility and importance of time series forecasting in our modern world. Stay tuned to explore these fascinating case studies in depth. Let's dive into a case study that highlights the transformative power of time series forecasting in a business context. Imagine a retail company looking to optimize its inventory management. By implementing time series forecasting, the company can predict future sales trends with high accuracy, allowing them to make data driven decisions. During peak seasons, this predictive capability helps ensure that stock is replenished at the right time, avoiding stockouts or overstock situations. It also aids in financial planning and budgeting, as the company can forecast revenue streams and align their financial strategies accordingly. Using time series forecasting, the business can stay ahead of market demands, reduce costs, and increase profitability. The impact on decision making is profound. Executives can move from reactive to proactive strategies, informed by a consistent stream of reliable data. In this segment, we delve into a real world application of time series forecasting: stock market analysis. Time series forecasting is a powerful tool used to predict stock prices and market trends, providing invaluable insights for investors and traders alike. By examining patterns and trends, time series forecasting helps to make informed predictions. One popular method is to evaluate past performance of stocks, identifying upward or downward trends, seasonality, and other patterns that may indicate future movements. For example, an investor might use historical stock prices, trading volumes, and other financial indicators to identify potential entry and exit points in the market. This analysis can significantly improve the decision-making process and potentially maximize returns. Ultimately, the ability to predict stock prices with a certain level of accuracy can transform investment strategies. However, it's crucial to remember that while time series forecasting can provide valuable insights, it doesn't eliminate risk entirely. It's still essential to consider other factors, such as market conditions and global events. Weather prediction is another critical application of time series forecasting. By analyzing historical weather data, we can predict future weather patterns with remarkable accuracy. This capability is vital for planning and ensuring safety across various sectors. For instance, timely and accurate weather forecasts can help farmers decide the best time for planting or harvesting crops, potentially saving an entire season's yield. In the aviation industry, precise weather forecasts are crucial for flight safety and scheduling, minimizing delays and disruptions. Additionally, emergency services rely on accurate weather predictions to prepare for severe weather events, enabling proactive measures that protect lives and property. These examples underscore how integral time series forecasting is in weather prediction, influencing everything from everyday activities to critical safety decisions. As we approach the final segments of our journey through time series forecasting, it's time to delve into advanced techniques. Traditional methods have served us well, but with new technologies, machine learning and deep learning are taking center stage. These powerful tools are opening new frontiers in forecasting accuracy and reliability. Machine learning methods, such as support vector machines and decision trees, capture complex patterns that traditional methods might miss. These models adapt quickly to new data, providing robust and flexible forecasts. Deep learning methods, like recurrent neural networks and long short-term memory networks, excel in handling large data sets with intricate temporal dynamics. These models learn from vast historical data, identifying subtle shifts and trends that lead to highly accurate forecasts. Exploring these advanced techniques enhances your forecasting capabilities and equips you with a competitive edge in data science and analytics. Next, let's recap the core principles of time series forecasting and how to apply these advanced methods to real-world scenarios. As we wrap things up, let's take a moment to review the main points we've explored throughout this video. First, we delved into the essential components of time series data, breaking down trends, seasonality, and noise. Understanding these elements is critical for accurate forecasting. Next, we examined various forecasting methods, ranging from simple techniques like the moving average to more complex models such as ARIMA and advanced machine learning methods. We also looked at real-world applications of these forecasting techniques, highlighting their importance in business forecasting, stock market analysis, and weather prediction. By mastering these concepts and methods, you can significantly enhance your ability to make accurate predictions and informed decisions based on time series data. As we move to our conclusion, remember that the journey doesn't stop here. Practice applying these techniques and stay curious about the evolving field of time series forecasting. Thank you for watching our in-depth exploration of time series forecasting. We hope this video has equipped you with valuable insights and practical techniques to tackle your forecasting challenges. As you apply these methods, remember that practice and persistence are key to mastering any new skill. If you found this content helpful, we invite you to subscribe to our channel. By doing so, you'll gain access to more educational videos on data science and analytics designed to support your learning journey. Stay engaged, keep learning, and apply what you've acquired to solve real-world problems. Your journey in data science doesn't end here. It's just beginning. Thank you once again, and we look forward to seeing you in our next video.